Sir, they are removed in the slag. Means
Very
they
good,
come
very good.
out.
Because, right, exactly. The ash content in the coal or coke is nothing but silica, mostly. They are SiO2. So SiO2 means obviously they will join the slag phase anyhow. You have to remember that. So coke contain very less amount of ash, but coal contain lot of ash content, right? So if more ash, more volume of slag will be there. Huh? And one point you forgot to mention, coke is also permeable. Hmm. It has certain porosity in it, so it has good reactivity. Okay, so these are good points. But if you take a coal are not permeable basically. But coke is permeable. Coke is strong and permeable. But coal is not permeable. It is fragile also. Coal is fragile. It will break into pieces. Coke will not break into pieces easily. It is very high strength. Anyways, so today's topic is recent trends in blast furnace practices or modern trends in blast furnace practices. So the first point, the what is the main objective of this? What are the why we are adopting new practices? What is the objective? You have to remember there are two
To
objectives. The first objective is we have to increase the productivity. That is the main objective. Huh? And second objective is we have to reduce the consumption of coke. So you might get a question, or you might get a question in interview also. What are the recent uh, practices going on in the steel industry for blast furnace, and why they are adopting these practices? So obviously the objective is either to increase the productivity, basically, or to reduce the consumption of coke. Why to reduce the consumption of coke? Because coke is expensive in nature, right? And we don't have plenty of metallurgical coal available, right? Anybody remember example of metallurgical coal or coking coal? Because coke can only be formed from metallurgical coal or coking coal, right? You cannot make coke out of any kind of coal. We have lignite, peat, bituminous, and there are various types of bituminous are there, anthracite. We cannot use any kind of coal to make coke. Only metallurgical coal or only coking coal can be converted into coke. The amount available in nature is very less. That's why the coke is also very expensive. And production cost of coke is also expensive, right? So coke is the only raw material for iron making which is expensive. So if you reduce the amount of coke consumption, that means you can reduce the production cost. You can make the production of iron economical. I think you people have understood up to this point. Is it
Yes,
okay
sir.
to this?
Yes, sir.
Yes, sir.
Okay, so I'll start from the top. Huh? Just imagine this. Just have a look. Huh? This is the blast furnace. Huh? You can see the watermark blast furnace. Huh? So I'll start from the top. So first modern practice the industry are adopting is high top pressure. Listen it carefully. That is called high top pressure. So that means at the top of the blast furnace, they are maintaining a high pressure. That is the concept. So how they are doing? How they are maintaining a high top pressure, right? So what they are doing basically, if you remember, what happened to the blast furnace gas? Anybody remember? What happened to the blast furnace gas or top gas? It goes to the uptake, right? Then from uptake, it goes to the downcomer. Anybody remember? Then from downcomer, it goes to the dust catcher. Then dust catcher, then it goes to the scrubber. Then finally, it goes to the ESP, right? Then finally, it goes to chimney. Or it can be goes to the blast furnace stove basically for combustion purpose. So what exactly we are doing? From the scrubber, there is a different route. So we sent some of the cleaned gas after scrubber back into the furnace again from the top. right? That means the top gas is moving upward. It is going to the down uptake, then to the downcomer, then to the dust catcher, to the scrubber. From scrubber there is another connection. So one some amount of gas will go to ESP, and some amount of gas will come revert back into the furnace again from the top, right? So what will happen? There will be a generation of high top pressure, obviously, because the gas want to come out, but you are flowing gas in the opposite direction from the top. It's okay or not? It is clear.
Yes, sir.
Yes, sir.
Actually, I don't have anything to draw it right here, right? But if it will be a blackboard, I can explain you in a good way, right? But still you have to imagine. So you people understood how high top pressure is maintained. So now the question is, if you are maintaining high top pressure, what is the advantage? See, just imagine, huh? The hot reducing gases is moving up, and you are supplying a pressure from the top. So what will happen? Obviously, the residence time of the reducing gas will be increased. Yes or no? They cannot easily escape out of the furnace. They will remain for long interval of time inside the furnace. So if they stay for more interval of time, also with high pressure, so what will happen to the reduction? Reduction will be better. So if reduction will be better, production will be good. The rate of production will be good, right? The coke consumption will reduce, obviously. You people understood my point?
Yes, sir.
Yes, sir.
Because you are supplying hot blast from the bottom, and that hot blast is converted into hot reducing gases, and it is moving at a very high velocity to the top, and it is coming out of the furnace. So some carbon monoxide is reacting and some carbon monoxide is unutilized. It cannot react because it is coming out of the furnace, but you are providing a gas from the top to maintain a high pressure. So if you maintain a high pressure, this carbon monoxide cannot escape easily. It will stay for more interval of time, and it will react with the coke. Sorry, it will react with the iron ore in a better way. And pressure is high, so penetration power of carbon monoxide is also good, and residence time is also high. So reaction will be good. That means reduction will be very good way. The reduction will be good, or the reduction will be increased, and the rate of production will be high, and consumption of coke will be also less. It is okay. I think you people have understood up to this. Shall I
Yes, sir.
move to next?
Yes, sir.
सर
Yeah.
सर ये
हाँ हाँ पूछो. Yeah, you can ask.
सर ये ब्लीडर वेल्व का भी तो यूज हाई टेम्परेचर में हम लोग कर सकते हैं क्या, कि हम
Yes.
लोग गैस को ब्लीडर वेल्व जो डाउन कमर वहां पर अपटेक में गैस चल गया हॉट मतलब फ्लू गैसेस ये सब, और उसके बाद ब्लीडर वेल्व उधर रहता था ना, तो उसका कैपेसिटी अगर हम लोग बढ़ा देंगे तो हाई टेम्परेचर को एनहेंस कर सकता है क्या?
एक्चुअली मैंने तुम्हें कॉन्सेप्ट बताया, बट उसमें वो वाल्व वगैरह लगा रहता है, ठीक है? वो एक्चुअली ना, तुम्हारा जो स्क्रबर है, स्क्रबर से कनेक्शन रहता है, फिर से ऊपर से तुम सप्लाई कर सकते हो, और एक ट्यूब जाता है दूसरे डायरेक्शन में, बैक साइड डायरेक्शन में, ठीक है? तो स्क्रबर से कनेक्शन रहता है, बट ब्लीडर का पता नहीं, मुझे आइडिया नहीं है बेसिकली.
सर वो अपटेक और डाउन कमर के बीच में एक वाल्व रहता था ना, ब्लीडर वाल्व,
अच्छा,
जब
हो
अंदर
मे
का
बी,
प्रेशर।
मे बी वही हो सकता है. आई एम नॉट श्योर. मे बी दैट इज द वाल्व.
सर अगर इसको ऐसा नहीं करके हम लोग ऐसा करते तो जैसे ब्लीडर वाल्व का कैपेसिटी हम लोग बढ़ा देते तो अपटेक में ज्यादातर गैस रुक जाता, तो इसीलिए थ्रॉटलिंग मतलब थ्रॉटलिंग बैक हो जाता गैस, और उसके वजह से रिडक्शन बढ़िया हो जाता.
See, this is a throttling process only. This height of pressure is nothing but a throttling device. You are using actually a throttling device to revert back the gas, right?
जी सर, इसमें हम लोग वापस फिर गैस ऊपर से हम लोग भेज रहे हैं, लेकिन हम बोल रहे हैं कि सिर्फ ब्लीडर वाल्व का कैपेसिटी अगर हम लोग बढ़ा देंगे तो जो जो डस्ट मतलब ये
तुम ये नहीं
फ्लू
समझ
गैस.
रहे हो कि सॉरी, यू आर नॉट गेटिंग दैट. Then what is the need of cleaning the gas? They are actually cleaning the gas, na? The gas will pass through the dust catcher. The coarse particle will get separated out, right? Then they will pass the gas through the scrubber, then finer particles come out. They are then again the clean gas will be sent into the furnace. They are not sending the dust gases, the gases containing dust. You understood my point?
Yes, sir.
uh, I think you understood, right? We are cleaning the gas, then we are sending it back. We are not sending directly the gas containing dust, big size, big particles. It may clog the porosities, right? Or it may clog the voids, right? That's why maybe that may be the reason. Or maybe there will be a wear and tear of the refractory linings if you send back the gas containing dust, right? I think you understood up to this, huh?
Yes, sir.
Okay, second most important practice is actually this kind of practice is already planned by Tata Steel. Huh? Tata Steel is planning to install this one recently. So that is called uh, injection through injection through stack. You have to remember injection through stack. You know the stack region or shaft region, right? So in the shaft region or in the stack region, which kind of reduction is going on? Direct or indirect? Mostly in the stack region of the blast furnace, which kind of reduction is occurring?
Indirect reduction.
Indirect reduction. Indirect reduction means carbon monoxide will react with iron ore rather than the direct carbon, right? So if you inject carbon monoxide through the stack by by installing some two-year kind of thing or installing some pipes, right? So it will increase the, obviously it will increase the rate of reduction, right? So there, this is a very good technique, huh? You suppose you are cleaning the top gas, and again this top gas will be purged through the through the tuyer which is installed in the stack portion. So that will help in the reduction process. You can minimize the consumption of coke by this process, or you can generate some carbon monoxide in any other region, and you can purge that carbon monoxide into the stack region, through a tuyer, through pipes. So it will increase the rate of reduction process, and in this way you can reduce the consumption of coke also. That is another practice, huh? Okay, fine. This is the second one. Third one is, obviously people know, we can increase the dimension of the furnace. Anybody remember which dimension of the furnace is very important? One is the working height and working volume. You remember the concept, working height and working volume? Anybody remember what is working height? What is working height of the blast furnace? From where to where?
So about 20 to 30 meters.
No, I'm not asking the data. I'm asking from which region of the furnace to which region of the furnace is called working height. Because there are three heights. One is working height, inner height, and total height, basically. Working height is the height in which the furnace is working. That means important reduction or important reactions are going on in that particular height. And that entire volume is called working volume also. Obviously, from the tuyer to throat, or tuyers to stack, the upper layer of the stack. That is called, yeah, that is called throat, basically, or um, I forgot the name exactly. That is also called throat. And stalk line, yeah, stalk line. From the tuyer to stalk line, that distance is called working height. Why? Most of the reaction are going on in that particular region, particular height. So nowadays, industry people are doing what? They are increasing the height of the furnace. Like they are making the furnace to 40 meters nowadays, 35 to 40 meters. Earlier days, the height of the furnace was only 20. Nowadays, the height of the furnace were 40 meters. You can imagine. They are increasing the volume of the hearth. Hearth volume is increasing. They can store more amount of hot metal and slag in that. And other things are okay. This is the third point. Fourth point is you instead of lump, you can directly charge sinter and pellets, right? Sinter and pellet charge is also very good, right? That means you convert the iron ore into sinter, you convert the iron ore into pellets, and you can charge it into the furnace. You can get a high, you can get high productivity, as well as you can reduce the consumption of coke also, right? Because sinter and pellets have very high strength and they have also good reducibility. That is the important point you have to remember. Sinter and pellets have high strength as well as they have high reducibility. Why? Because they contain pores also, right? They contain also pores. If pores will be available, carbon monoxide can easily penetrate into it, right? And reduction can be easier. Okay. But if you charge lump, only lumps, lumps are natural occurring things, right? They don't contain any kind of porosity, basically. Okay. But sinter and pellets contain porosity. And sometimes the strength of the sinter and pellets are higher compared to these lumps. Okay. So it is better. And and another point is if you use 100% pellets, that is also that can give you a good advantage. Can you tell me, can anybody tell me, if you charge 100% pellet into the furnace, what kind of advantage you can get? Anybody have any idea how pellets looks like?
Sir, almost spherical shape.
Spherical shape, right? So that will give you the answer. Can you tell me, if you are charging spherical particles, what will happen? What kind of advantage you may get?
More surface area, then better reduction.
Surface area? No, you'll get more voids, and that is of uniform voids. If you stack atoms one over another, you are getting voids. You remember that interstitial voids, right? Same interstitial voids you'll get here only, right? And that will be a uniform voids also, basically. So lot of voids you'll get, lot of permeability you can obtain by this. If you charge 100% pellet, you can obtain lot of permeability, lot of voids, and flow of hot gases will be easy. Flow of hot metal and slag will be easy, right? So these are the advantages you will get, right? And obviously, you can understand, we cannot charge fine particles into the furnace, right? You remember what are the problems? So the best solution is you can convert this fine into pellets, right? There is a criteria always you have to remember. If the particle size after crushing and grinding, if it is below 10 mm but above 5 mm basically, then you can convert that particles into sinter, right? But if the particle size is below 5 mm, less than that, right? Suppose 1 mm, 2 mm, like that, you can convert those particles into pellets better. So this is another recent practice going on, right? Okay, next we'll move into the 2 year portion, huh, which is very important part. This part you might get questions in end semester. Huh. What are the things we are doing in the 2 year portion? Actually, we are injecting lot of things through the 2 year. The 2 year is the part where we can inject lot of things into the furnace, right? That is the pathway. Huh. So first one is, you have to remember, from the 2 year we are supplying hot blast, right? So in the recent practices they want to increase the temperature of the hot blast, right? Why? Because if you increase the temperature of the hot blast, that means externally you are supplying more heat into the furnace. So obviously the consumption of coke will be reduced, because already you are supplying heat through hot blast. That hot blast contains some temperature, right? So earlier days they used to provide hot blast at a temperature of only 600, 700. But nowadays they are providing hot blast at a temperature of nearly 1000 degrees centigrade, 950 to 1000 degree, you can imagine. from 600 to nowadays 1000 degrees centigrade. So more heat input you will give through hot blast, obviously the consumption of coke will be reduced, because consumption of coke means coke also burns to give you heat energy. But if you are supplying heat energy from through the hot blast only, hot air with high temperature, you can reduce the consumption of coke. That is very advantageous, right? Can anybody tell me how it can be done? How you can increase the temperature of the hot blast? Just modifying the stove, right? Hot blast is created in the stove, right? Anybody remember? I explained about the stove in the second lecture, maybe. I don't remember that. In that part, I have explained how we can modify the stove, blast furnace stove. If you remember, the blast furnace stove can be modified. I told you that means there is a combustion chamber, there is a checker bricks chamber, or yeah, combustion chamber and checker bricks chamber. If you increase the volume of the checker bricks chamber, you can increase the heat capacity. You can store more amount of heat, right? So in modification, you remember we convert the dome into combustion chamber, and entire remaining part becomes the checker bricks, right? That is one modification I told you, if you remember. And another modification, if you remember, you can do combustion outside of the stove, and entire stove will become the checker bricks. It is okay up to this? I think you people are getting the point, huh?
Yes, sir.
Yes, sir.
So if you keep more amount of bricks in the hot blast stove, you can store more amount of heat. If you can store more amount of heat, you can increase the temperature of the hot blast. So this is the way they are increasing the temperature of the hot blast, right? By storing more amount of heat. This is one part, huh? And another part is you can increase the volume of the hot blast. The hot blast volume, which they are supplying into the furnace, that can also be increased. So what is the advantage? Can anybody guess? If you increase the volume of the hot blast, what is the advantage you will get? What exactly I mean to say in that?
Better reduction.
Yeah, better reduction. See, actually, why we are supplying this? Actually, see, if you supply more volume of hot blast, that means indirectly you are supplying more volume of oxygen, which is required for combustion, right? So more oxygen, more combustion. So more better combustion will take place, and more energy will release, obviously, right? So by increasing the volume of hot blast, you can increasing the combustion power of the inside the furnace, right? So by this, you can also decrease the consumption of coke. You can increase the production rate. This is another thing, right? Now moving to other points, one important point is oxygen enrichment. You have to remember oxygen enrichment in the hot blast. Hmm. What exactly it means? Basically, in earlier days, they are supplying only hot air. Hot air means most of the part of the hot air contains what? Nitrogen. You people remember the composition of normal air, right? The maximum part is nitrogen. How much nitrogen is there in our air? Anybody remember?
70%.
78% nitrogen.
How much?
78.
78 to 79, yeah, right.
Yes, sir.
78 to 79%, you can imagine. And rest 20% is oxygen, right? So that means if you supply only air, that means you are supplying more amount of nitrogen, right? But supplying less amount of oxygen. And you understood nitrogen never take part in combustion, and nitrogen never take part in the reduction process. So what will happen? Is it good or bad?
It's bad because it carries heat away from the blast furnace.
Exactly, it is bad because nitrogen never take part in the combustion process, and nitrogen never take part in reduction process, but nitrogen is still there, right? It is called nitrogen dilution sometimes. So nitrogen is there, that means nitrogen also get heated up to high temperature. It is consuming the heat. It is not helping, but it is consuming the heat with it, right? Because if you measure the top composition of top gas, you will find nitrogen also, right? Obviously nitrogen is there, but it is taking away your heat energy, right? So you are losing the heat energy because nitrogen is taking away the heat energy. It's neither take part in the reaction, neither take part but rather than it is taking away the heat because of dilution, right? So that's why if you enrich the hot blast with more oxygen, then it will be advantageous. The combustion rate will be high, nitrogen dilution will be less, so less amount of heat loss will be there. I think you people understood up to this. That means in the air we have 78 to 79% nitrogen. You have to reduce the amount of nitrogen, but you have to increase the amount of oxygen. Oxygen amount is only 20 to 21. So make it like 60 70% oxygen, right? So similarly your nitrogen amount will be reduced in the air, right? So that is called oxygen enrichment of the hot blast. So by doing this, you can increase the productivity, you can decrease the consumption of coke, right? And another one is called humidification of hot blast. That is also very interesting. Humidification of humidification. If this names come from humidity. Humidity means moisture, right? So that means we are introducing some moisture into the hot blast through the tuyer, right? So what is the advantage of this? If we introduce moisture into the tuyer region, what is the advantage? Moisture means what? H2O, water is there. So this water molecule will react with carbon, right? So what will happen? H2O plus C, it gives rise to CO plus H2, right? H2O plus C gives rise to H2 plus CO. Is it okay now? You people understood my point?
Yes, sir.
Yes, sir.
And carbon monoxide and hydrogen, both you are getting. If you are introducing only hot blast, you are getting only carbon monoxide, because hot blast contain oxygen, it will react with carbon to form carbon monoxide, right? But if you are introducing water molecules with hot blast, then you will get hydrogen as well as carbon monoxide, and both are reducing gases. So by supplying 1 mole of H2O, you are getting 2 moles of reducing gases. Very interesting. And hydrogen is also a good reducing agent because of its small size. It can easily penetrate into the ore. Its kinetics is good, right? So this is an advantage. By introducing only water, you can generate more amount of reducing gases. One is hydrogen, one is carbon monoxide. So obviously the consumption of coke will reduce to a large extent. The production rate also increase because of faster reduction process. I think you people understood this one, right?
Sir, is
This
there
is,
any limitation in oxygen enrichment? Means what amount of percentage we can, what amount of
yeah,
oxygen we can
limitations.
induce?
If you talk about limitation, the cost will be higher, because it is very difficult to remove nitrogen, right? Nitrogen is already there in the air. You have to remove the nitrogen, you have to increase the amount of oxygen, and that process is obviously expensive process. Because you understood now, you cannot separate one molecule of nitrogen from one molecule of oxygen. They are already mixed kind of, no? They are gaseous phase, they are mixed. It is very difficult to separate them. So the process will be expensive if you are increasing the amount of. And if you talk about how much oxygen we can we can supply to the blast furnace, you can supply 100% oxygen, there is no issue. You can do that, but the process will be expensive. Is it okay now?
Okay, sir. Yes, sir.
Yeah. So this is okay. I talk about humidification, I talk about oxygen enrichment, right? Then yeah, you have to remember one important point here. Humidification of hot blast is an endothermic process. You have to remember. It's not an exothermic. It is an endothermic. Endothermic process means the process which consume heat energy. It will reduce the temperature, right? So do you think if a endothermic reaction will happen at the 2-year portion, it is advantages or disadvantages?
Disadvantages.
Obviously disadvantages, right? Because you don't want to lose heat. But if this kind of endothermic reaction will happen, then it is consuming the heat energy. So that's why in exam people ask this kind of question: why oxygen enrichment is always done with humidification of hot blast? Can anybody justify this?
Sir, oxygen enrichment is a exothermic process, and
Very good, very good. Yeah,
to counter the endothermic process,
exactly.
the humidification at last, we are using oxygen
Very
enrichment.
good, very good.
Also in
So you
blast
people are,
furnace,
yeah, 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 yeah.
sir,
Please
also
go
in
on.
blast furnace, other endothermic reactions are happening, such as reduction of SiO2, P2O5, MnO, and all. So that's why we are inducing the oxygen enrichment process.
Yeah. If you supply oxygen, more exothermic reaction will happen, right? But if you supply water molecule like moisture, that is an endothermic process. So that means, as he told, to counteract this endothermic process, we are supplying oxygen. Because if you supply more oxygen, more exothermic reaction will happen. If you supply more moisture, more endothermic reaction will happen. So that's why it is better to do both things simultaneously. If you are doing humidification of hot blast, you also inject more amount of oxygen into the furnace. That is good. You get the benefit, main benefit out of that. Right? Okay, so this is the part. Next trend is humidification is over, oxygen enrichment is over. Yeah. Next is a very important modification, that is injection of PCI. You have to remember, injection of PCI. PCI means pulverized coal injection through tuyer. Through the tuyer, we can inject very fine particles of coal, and that coal is actually a non-metallurgical coal, or like you understood, like peats, lignites mostly. Hmm. It is okay now. So if you inject fine coal particles, which are basically non-metallurgical coal, you'll get lot of advantages. One advantage is, if you inject fine particles, that means suddenly they will react with oxygen to form carbon monoxide, right? So you can generate more amount of carbon monoxide by injecting fine particles of coal at the two-year region, right? So obviously, coke consumption will reduce, because our important point is we have to reduce the consumption of coke. If you inject PCI now, then you can reduce the consumption of coke. Because coke, one of the function of coke is what? It will undergo combustion and release carbon monoxide, right? But our aim is to reduce the amount of coke, right? We cannot charge coal from the top, but there is a solution to charge coal that can be charged through tuyer in form of fine particles, because it only its main function is to undergo combustion and to provide carbon monoxide, right? So in this way, if you provide fine particles of coal through tuyer, you can reduce the consumption of coke by generating more amount of carbon monoxide. Okay, but any limitations? Can you tell me, then if this is the situation, why then if this is the situation, then we can reduce lot amount of coke. Is it possible? Can we reduce lot amount of coke in the furnace? Suppose we are charging more amount of PCI, can we reduce the amount of coke to the large extent?
No, sir, dust loss will be there.
Sorry, yeah, can you repeat what you're saying?
No, sir, the dust loss will be there. Heavy
No,
dust
no,
loss
no,
will be there,
no.
and ash content will
What
be
kind of
also
dust? There
increased.
will be no dust loss. My question is, suppose, as I told, if you can charge more amount of PCI through tuyer, Can you reduce the amount of coke? We can reduce the amount of coke, but can we reduce the amount of coke to a large extent? My question is that.
No, sir, we can't reduce because at the starting point we need high temperature.
Mhm. You are forgetting the important part of the coke. Coke is the only substance which provide permeability at the Bosch region because it remains in solid state. So you need a particular optimum amount of coke that will sustain the burden, that will sustain the load on it. If you reduce the amount of coke to a large extent, what will happen? The amount of coke will be reduced, then it cannot sustain the load. It will break into fines. You people are getting my point or not? Okay,
Yes,
fine.
sir.
Let me explain in an easy way. Suppose 10 people are standing, they are holding a load over them, right? Ten people are standing, they are holding a load over them, right? But suppose I will reduce it to 8. Is it okay? It will be okay, fine. Even then they can sustain the load. But if I reduce it to 5, what will happen? Or if I reduce them to 4 people now, they will collapse. Yes or no?
Yes, sir.
Yes, sir.
Obviously, earlier first case is 10 people are holding the same amount of load. But now I am reducing it to 8. Okay, fine. It is again fine. But if suddenly I reduce it to 5 number of people, the same load, what will happen? They all will collapse. So same thing happens to the coke. If you reduce the amount of coke to a large extent, then what happens? That amount of coke may collapse. They may become fines. So there will be no permeability in the Bosch region, right? So we need a particular value of coke need to be maintained. But by injecting PCI, we can reduce the amount of coke anyhow, but not to a large extent. So this is one of the limitation. And second limitation is if you inject more amount of coal, what happened to the slag volume? What happened to the sulfur content? What happened to the silicon content of the hot metal? Can you tell me? These are the three questions. If you increase more amount of PCI injection into the blast furnace, what will happen to the hot blast, hot metal composition related to sulfur, silicon, and what will happen to the volume of the slag?
The
You
volume
people
of
have,
slag it increases.
sorry, yeah,
Volume increase it was a slag.
slag volume increases. Okay, why? Why it will increase?
More amount of gang, no, more amount.
Sorry, can you be louder? Can you please louder? Huh?
Sir, ash content बेसी ହେଇଯିବ ତ slag ର
Yes,
volume
yes,
ଟା.
right. Very good. Because we are injecting pulverized coal injection, that is actually a coal. Coal means more ash content. More ash content means more volume of slag, obviously. Very good. And what happened to the silicon content and sulfur content of the hot metal?
Sir, all have ମାନେ ସବୁ ହିଁ ବଢିବ.
Yes, obviously, because the sulfur content in the coal is very high. So obviously that will join to the metallic phase. So more sulfur content will be there in metal. Similarly, more ash content means more SiO2 content. Some SiO2 will get reduced to Si. Obviously, they will join to the metallic phase. So obviously, if you inject more amount of PCI, then at the end you might get more sulfur content in hot metal, more silicon content in hot metal, and obviously the slag volume also increases because of more ash content in the coal. So that is the limitation of PCI injection. I think up to this it is clear to everybody. Okay, next we'll
Yes,
move
sir.
to another kind of injection through two ear, that is called lime injection through the two ear. Lime injection. That means we are injecting CaO through the two ear. That will give you another advantage, right? Because sometimes we need lime, right, to make the perfect slag. Because if you can make a perfect slag, you can make a perfect hot metal. That is the point, right? So in this connection, I can say like this: uh, we have three kind of slag basically. Three kind of slag in the blast furnace. First slag is called primary slag, that is formed at the lower stack region of the blast furnace. Hmm. Lower stack region of the blast furnace, or just upper part of the Bosch region, you can say. That is called primary slag. That composition of primary slag is what? FeO.SiO2.Al2O3. It is a ternary compound. It is a low melting point compound. FeO.SiO2.Al2O3. Right? It is a ternary compound. So it is having a low melting point. So this slag forms earlier first. Hmm. Then second kind of slag is called Bosch slag because it formed at the Bosch region. So primary slag is actually acidic in nature, but Bosch slag is basic, right? Why it is basic? Because you understood, suppose you are supplying, you are injecting lime, then lime will react with silica and alumina to form CaO.SiO2.Al2O3. So it is basic, right? Or in another way, if you are supplying limestone from the top, then limestone will undergo calcination, then lime will be free, then lime will react with SiO2 and Al2O3 to form CaO.SiO2.Al2O3. Okay, this is called Bosch slag. And final slag is the hearth slag, slag which forms at the hearth region. That is called final slag. Final slag will be again acidic. Hmm. So primary slag is acidic because silica is there, and FeO is a weak oxide, weak basic oxide. That's why. And Bosch slag is basic slag because lime is more basic than that of iron oxide. And final slag is the again acidic. Why? Because I told you we are injecting PCI through the tuya. If you inject more PCI, more silica will come out. That will go into the slag. So more SiO2 means more acidic because SiO2 is acidic, FeO is a weak base, and CO is a strong base. Right? You have to remember these points. And Al2O3 is a amphoteric oxide. So primary slag is FeO dot SiO2.Al2O3, which is acidic. Why? Because FeO is a weak base, but SiO2 is a strong acid. Hmm. And second one is the Bosch slag. Bosch slag means FeO will be removed, lime will attached to form CaO.SiO2.Al2O3. So it is a basic slag. Why? Lime is a strong base compared to FeO. And final slag is what? Final slag is again same slag, CaO.SiO2.Al2O3, but some amount of more amount of silica will be there, SiO2 will be there, because it will be released from combustion of the coal, which we are supplying through to air in form of PCI. So this is the concept. And another point you have to remember, uh, the hearth temperature. The temperature of the hearth is nowadays they are maintaining very high hearth temperature, like 1400 degrees centigrade, 1450 degrees centigrade. In Japan, they are doing this is the practice they are doing in Japan. They are maintaining high temperature of the hearth, like 1400, 1450. But in India, I'm not sure about that. But in earlier days, they used to maintain only a temperature of 1250 to 1300 maximum hearth temperature. But in Japan and some other countries, they are maintaining very high temperature of the earth. So what is the advantage? You can make the process continuous if you maintain high temperature, right? Because after getting hot metal, you can convert the hot metal into steel, then you can process it, then you can cast it, you can roll it, you can produce any component directly without losing much amount of heat, right? So that is the advantage, yes. And other advantage is nowadays people are also injecting plastics into the furnace. So if you inject plastic through tuya, what kind of advantage you get? Can anybody tell me, if you inject plastics, waste plastics into the tuya, what kind of advantage we can get? Plastics are basically what? Plastics are basically hydrocarbons. They contain hydrogen and a carbon, obviously. So that means if you inject waste plastic into the 2-year resin, you can get hydrogen gas and carbon monoxide gas both. And also you can get heat energy due to combustion. Three things. You get heat energy by combustion of plastics, you are getting hydrogen gas, you are getting carbon monoxide gas, and both are reducing gases. So reduction will be good. And you can also control the waste. Plastic is a waste, no? You can control the waste. But we need to be careful. It should not contain any kind of chlorine actually. Those plastics should be chlorine free. That is not good for refractory linings. But chlorine are very dangerous for the refractory line. They can degrade the refractory linings. So chlorine should be removed from the plastic. Then we can inject, because you remember plastics are PVC also, polyvinyl chlorides. We have to remove those chlorides or chlorine first. So these are the recent trends. Another point I forgot to mention, that is uniform distribution of burden. In earlier days, they use this bell arrangement system. But it has been modified to chute, rotating chute. Rotating chute will leads to uniform distribution of burden is very important. That will rotate in a 360-degree manner and distribute the burden uniformly inside the furnace, so that reduction will be proper and good. So all these are about your recent practices or modern trends in blast furnace iron making. Any questions you have from this? Okay, fine. If you don't have any questions, I'll stop here. But I'm sure you will get some questions from this part.